thank you very much. It's always something I learn when I come to Cambridge area. This time I learned, so I want to welcome you to the graveyard talk. Thank you for staying. It's great. And I'd like to, since I'm the last speaker, I'd like to thank Fraser and Marcus for putting together such a great set of talks. Thank you very much. Thank you for the opportunity. I really enjoyed it, seeing all the fellow technologists who I'm a physicist, by the way. I'm sorry. I'm sorry for that. Can't change it. You're born physicist, I think. Nevertheless. I'll be talking or presenting a little bit of what we do. We are, we are a bit a niche of a niche of a niche. So we are applying digital printing to electronics. So we actually come from electronics. We are coming from a microelectronics world. And I think I should show you the presentation. And I just want to give you the PCB just to show. This is what, so the green lacquer, this is what has been printed with inkjet. Yeah. So in this last session, we heard Clive gave an introduction to additive manufacturing. We are doing additive manufacturing, but with a slightly different viewpoint, where, say, when you think about additive manufacturing, you very often think about being 3D printing, and so where a lot of the industry of the 3D printing industry is they are astonished by, well, we can 3D print, and then we want to go to market, we want to go to high volume production. We are looking at it and from another angle. So we are in high volume production producing PCBs, so that's what we know. And we want to look at the processes where we can add value by using digital printing. And I'll present some of that in my talk. I'll start with the basics, how electronic devices work, how they are manufactured, our vision of making electronics more sustainable by using inkjet. I'll come to the company introduction and to some outlook in the end. So how do electronic devices work? If you look at the electronic devices, they are actually quite simple. So electronic devices are made of structured functional layers. It can be a transistor if you combine the P and N silicon, oxide and metal layers. But if you combine them in another way, they can be a solar cell. If you combine conductive and non-conductive parts or inks, it can be a PCB, or even more intricate, it could be an OLED display. They're all functional structured layers. So how are they manufactured? Very often, if you go into manufacturing of electronic devices, you encounter what we call the lithographic process chain. So you start out with a substrate, you apply a layer, full coat, you apply a resist, so a second layer on the functional layer. You then expose the resist with a laser system, with a mask, with whatever. Usually UV light is involved. Then you develop the resist, so this is a wet chemical process. And in the fifth step, you actually structure your functional layer that you applied in the first place. And then you have to get rid of the resist. So you're down with a 6-step process to get your functional layer on the substrate. Now, you're all working in additive manufacturing, and you scratch your head, okay, what if I could print that? And this is the exact question that we had. Yeah? So just putting some figures there. If you look at the big chip manufacturing companies, talking about sustainability there, they're using 10 million gallons of water per day. So one large chip fab. So talking about water, I really like the talk of alchemy yesterday. So it's It's the same question, different industry. So me not being familiar too much with gallons, I know you are probably. So it's the equivalent of about 300,000 households. So of course, those big manufacturers, they understand that they have to change. They have water recycling facilities and stuff like that. But, well, whatever, it's always reduce, reuse, recycle. So it's better to not use that water in the first place. So what can we do about it? Our vision, so this is a bit maybe very easy, but, well, let's print those layers. And we are not the only ones having that vision. Let's do it digitally. Let's use inkjet to print those layers. And looking at it, the first step, or the challenge, of course, is to reach the same functionality over here with now putting more requirements on the ink, like the rheology. Can we print it? Can we reach the same functionality with an additive process? So I'd say there are two classes of applications that we've realized at Notion Systems, or they fall into two classes. One is very easy. We don't change anything to the functional layer at all. We just get rid of two steps. We just print the resist directly. Yeah. This, of course, you can only do if the resolution or the feature size that you want to realize on your substrate is in the range of what you can do with inkjet. So it's in the 20 micron range, somewhere there, 20 micron or above. So we can't print chips, but well, at least there's an application space where this can be applied. And the advantage, of course, is we don't change anything to the original material. So the functionality is there already. But we already reduced process steps, so it's relevant for production. The goal is, and I think there's somebody or someone in the audience who knows this very well. This is the goal, of course, yeah, to print the functionality directly. And you have, I don't know where the sample is. So this is an example where we printed the functionality directly. So it's really a functional solder mask printed digitally, and it took some time to do that. I'll go into the details later on. So going to the examples, and I don't want to go to the whole history over here. I just want to take this as one of the examples. I know, Mark, you know this probably better than I do. Just the takeaway from this slide is printing of OLED, inkjet printing of OLED devices. Yes, there are some production aims or production systems in field. We also contributed. But as you work back your way in history, you probably end up somewhere in Cambridge. Yeah. So it's really great to be here. And anyway, so the takeaway is it might take long until a new digital technology, especially in electronics production, is adopted and be relevant in production. Okay, about the same time in Heidelberg, or near Heidelberg, we started, or say not me personally, but our company started looking into processes for PCB industry, digital processes for PCB industry. How many? 5. Yeah, I'll do that. Okay. Again, I don't want to go to the details, but just remember the name Heidelberg Instruments over there. It has nothing to do with Heidelberg printing machines, by the way. And we've developed the process that you just see on this sample. And we are in production today with more than 2 systems. We have 15 systems for this process installed. We have a great market adoption, also we profit, in a sense, from installations that are taking place in Europe and North America. And yeah, we are very happy that this has been so successful. And I want to show you a video. I hope it starts. So that's the typical PCB manufactured in the classical way, and we just add value to the end user by printing the solder mask digitally. So he can replace or can get rid of a quite wasteful process for applying the solder mask. Now this is manually loaded, but of course there's an automation in the background. Of course everything integrated with an automated cleaning device that we make a point in using non-touching cleaning of the nozzle plate in order to have a long lifetime of the print heads. And yeah, we are seeing this being adopted in the market today. Together, of course, we wouldn't be able to do this without partners like Agfa, like Electra, like Tayo and the others providing the material which make these devices possible. So we are always working in an environment. So I'm coming to the company introduction in the last maybe 3 minutes of my talk. So what is our mission? We make electronics production more sustainable by the use of additive processes. So we develop and build inkjet equipment, scale up new functional processes to industrial production. And sometimes it looks like this. So what can we print? We print functionalities. We print conductives, dielectrics in electronics. We print optics. We print active layers, resists, adhesives, 3D optics. It's about 40 different processes that we've realized so far as a company. And I just give you some of the examples. So this goes out to you, Mark. This is a picture of an OLED inkjet printer that is used in R&D for printing OLED displays. This is an edge resist printer, so a printer to structure the copper structures on the PCB. So it's this class 1 application. So just printing the edge resist. This is the printer that it looks quite similar. It's the same machine, just different ink. That prints the solder mask. This is a printer for quite large glass substrates where we print conductive layers on with a cycle time of 24 seconds. We also do roll-to-roll machines for energy storage. And last but not least, we have applications in the semicon area when, of course, not the chips, but anything like MEMS and above. We have applications there. Oh yes, solar, I missed, 3D. 3D is a quite, so we've been introduced to 3D, but 3D optics is a quite interesting area because that's where the strong point of inkjet is in the 3D world. There's no other 3D process where you can combine different inks with different properties with each other. So you have this multi-material jetting. And if you apply it to optics, it's the only way to produce optical devices that can conduct light inside the lens. Yeah? So if you combine optical materials with different optical properties, you can guide the light inside the lens, which is not possible with any other technology. So we are working on that. We have single material optical printers in field already, and we are working on the next step right now. And of course, we have a lab system to develop all these processes in-house or at our clients. And maybe I will just close with that video. So it's the same machine, but now showing the same machine for the PCB, now showing it in full production. We see adoption in the market right now, and yeah. So it's combined with so you see the same printing process for the PCB. Some UV lamps over there. During printing, and of course the whole thing sits inside a line of PCBs. It can be flipped, so to print both sides. with the same robots, and yeah, depending on the throughput that you want to have, you either have one system or two systems side by side to print on both sides. Okay. Yeah, I think I'll skip that. So we have a big mother company. We are very happy that we are owned by RAG Stiftung. So there are some companies who are actually a sister of, or Evonik is now a sister of us. I think I don't know if they even noticed, but nevertheless, it's good to have a good background and good financial funding as well. Yeah, there's an international setup. We'll be moving into a new facility in Schwetzingen. So if you want to come and visit end of next year, we'll probably have some space. Now it's quite crowded, but of course we welcome visitors. And so what's next? So we are going to climb that additive electronics ladder, and we rather do it step by step than doing the full way in one go. Thank you very much for your attention.